Virtual Precalculus. This is a real-world example of using the law of sines to solve a problem. Finding the height of the Washington Monument. Alright there, Virtual Precalculus. I'm here at the Washington Monument to use the law of sines to measure the height of this thing. Okay? So there's a little trick that can help us do that. The first thing I'm going to have to do is measure the angle of elevation to the top of that thing from where I'm standing. And I learned how to approximate angles using a rule of thumb, as they call it. For most people, when they hold their fist out at arm's length, from their perspective, that fist subtends about 10 degrees of arc. So I'm just going to count how many fists tall that thing appears to be. Looks to me to be about 4 fists tall, so it's about a 40-degree angle of elevation to the top. Now I'm going to have to take 10 long steps toward it so that we're 10 meters closer. I'm going to pause it here while I do that, because it's kind of windy. Drop the computer. Alright, now I am 10 meters closer to the base of the Washington Monument, and I am going to do my fist estimation of angle of elevation to the top. Looks to me to be about 4 1/4 fists. Now, of course, that's a very rough guess. We could just round it off and say, there's someone flying a kite and they almost ran into me. You could just say it's 42 degrees from where I am. Alright, so we went from 40-degree angle of elevation to 42, and 10 meters closer. Don't know the height, don't know how far away I am, that's all I know. It's freezing cold, so I'm going to go home and we're going to work out together how to figure out how tall that thing is using the information we have. Maybe you want to pause it and try that on your own. Good luck. I'll see you back in my warm apartment. Here's a summary of our measurements, the 2 angles of elevation that I measured and the distance between those measurement points. We're going to use this to find out other information that we can easily. So for example, this angle x has got to be how many degrees if it's a supplement to 42? That's right, 138. And then the angle up at the top, y, has to be how many to fill out the triangle? Right, 2 degrees to make 180 degrees in that red triangle. So now we can use the law of sines to relate all these quantities. A, B, and 10 meters, 240 and 138 degrees. The law of sines for this triangle, for this red, weird-looking triangle, has to be like this. So what we're going to do is focus on the last 2 parts of this and use that and the value of 10 meters divided by the sine of 2 to find out the side B. How long is that side B? Multiply both sides by sine of 40 and find out that B is 184 meters, more or less. Now look at the green triangle. Using our knowledge about that hypotenuse, we can find the height. The sine of 42 degrees has got to be the height over 184, right? And so we're just one step away from solving for the height. Multiply both sides by 184 and bam, we've got it, 123 meters. That's not exactly right, but it's only about 20 or 30 meters off, which is not bad for measuring things with my fists on a windy day.